What's up? I'm Vin, and today I want to go through the June 2022 Algebra 1 Regents, so let's get started. So we're going through part 1, the multiple choice, and for the first question, we want to know which correlation shows a causal relationship. Alright, so for this one here, you could just kind of pick which one looks least like the others if you're not sure, but the more minutes an athlete is on the playing field, the more goals he scores. That is not true, because if I were to play in an NBA game right now and you could leave me on the court for about 10 hours, I probably wouldn't score one basket, so that's not true. The more gasoline that you purchase at the pump, the more you pay. That sounds very reasonable because there's no way to avoid it. Okay, there's no chance involved here. This is a causal relationship. The more gas you buy, the more you pay. The longer a shopper stays at the mall, the more purchases she makes. That one, not necessarily true, because if you're broke, you can't buy anything. As the price of a gift increases, the size of the gift box increases. That's not true. Just think of a diamond ring. That's a tiny gift, but it costs tons of money, so definitely choice 2. Question 2, we have a function here. We want to know which statement is true. And for this one, we could use the calculator. So what we could do for this question, we could go to y equals, and we could type in the function 3x minus 5. And now if we want to run through the answer choices, we could press second window, and we could switch this over the independent variable from auto to ask. And what that does is that when we go to the table by pressing second graph, notice the table's blank. So choice 1 said f of 0 equals 0, which is not true. F of 0 is equal to minus 5. F of 3 equals 4, choice 2 is definitely true because that's showing up here. Now, choice 3 said that f of 4 was equal to 3, but f of 4 is equal to 7, so that's not true. And then choice 4 said f of 5 equals 0, but f of 5 is equal to 10. So definitely choice 2 here. So we're going with choice 2, but just know you don't have to use a calculator for this. If you plug 3 into the function, that means we're replacing the x with 3. So we have 3 times 3 minus 5. That gives us 9 minus 5, which is equal to 4, so definitely choice 2 here. So question 3 is very wordy. We have Benny's Cafe mixed green salads cost $5.75, and additional toppings can be added for 75 cents each. Which function could be used to determine the cost in dollars of a salad with S additional toppings? So for these questions here, you want to make use of the idea that this is, for one, going to be a linear equation, and m, the slope, represents the rate. And this is the fixed cost, or the y-intercept if we were talking about just a regular line, not in a word problem context. So this is the fixed cost. So when we look at this question, the mixed green salad, this is the fixed cost. Okay, so this is fixed, this is not changing. And the part that is changing, the rate of change, is the cost of toppings are 75 cents each. So this represents the rate. So then, without even looking at the answer choices, I'm seeing here that C of S is going to be equal to the rate, which is 0.75, times S, plus the fixed cost is 575. And then from here, I just look to the answer key to see which answer choice does this match. And this is going to match choice 2. So for question 4, we want to know which expression is equivalent to this one here. So for this one, you have to be able to factor. But if you don't know how to factor, you could use the calculator to answer this as well. So this, we're looking for two numbers that have a sum of positive 5. And the two numbers also have to have a product of negative 6. So the numbers that are bouncing around in my head when I do these questions, I'm thinking here 6 times negative 1, and I'm thinking 3 times negative 2. And then maybe I would make this negative 6 times 1, negative 3 times 2. But these are the main ones that I'm thinking of. But now I need the numbers to have a sum of positive 5. So the numbers are going to be positive 6 and negative 1. So that tells me this is equal to x, and then we have positive 6 times x, and then we have minus 1 here. And this matches choice 4. But if you don't feel like doing this algebra, what you could do is you could type this into the y1 of the calculator, and you could type this into the y2 of the calculator, and see that the graphs are going to completely overlap each other. So choice 4 is definitely our answer. Question 5 is a linear inequality question, and we have Peter has $100 to spend on drinks. Bottles of lemonade cost $2 each, and we have juice boxes cost 50 cents each. X is the number of bottles of lemonade, and Y is the number of bottles of juice boxes. Which inequality models this situation? So these take a little bit of a thought experiment, but you just have to be careful for these. So X represents the number of bottles of lemonade. So if lemonade costs $2 each, then 2 times X would tell us how much we're going to spend on lemonade. And if juice boxes are 50 cents each, we're going to do plus 0.50 times Y, which is the number of juice boxes. And now this is the million-dollar question. Is it less than or equal to, or greater than or equal to 100? So this is where the thought experiment comes in. And just think about it. Peter has $100 to spend. This represents his total bill. So this is how much is going to show up at the register. And just think that if he only has $100 in his pocket, then his total bill has to be less than or equal to that amount. Because if his total bill is greater than the amount of money he has in his pocket, so this is like the amount of money in Peter's pocket, that if the total bill went over the amount of money he has on him, he wouldn't be able to afford it. So the total bill has to be less than or equal to how much money Peter has in his pocket, which is why this is going to match up with choice 3. Question 6, we want to know which domain is most appropriate for a function that represents the number of items f of x placed into a laundry basket. Now here's a big part, each day x for the month of January. So just know that when we're talking about domain refers to the x values. So when we look at how they're defining the x values here, the x values represent each day for the month of January. So if you think about this carefully, integers won't work because we can't have negative days of January. Whole numbers makes the most sense here because if we're talking about the days of January, that would be like January 1st, 2nd, 3rd, and so on. Rational numbers aren't going to work here because this number is rational and we can't have the 3/7 day of January. That just doesn't make sense. And for the same reasoning, 4 doesn't make sense because if I said the pi day of January, that also wouldn't make sense. So whole numbers, choice 2 is our answer. Question 7, we could do this in the calculator, but we'll just go ahead and do this algebraically since it is the Algebra Regents. We'll practice our algebra here. And for this one, I'll just subtract 5 on both sides. And that's going to wipe this out. We have 3 halves times b is less than 17 minus 5 is 12. So now to get b by itself, notice we have 3 halves in front. So we can multiply both sides by 2/3 like this. And now on the left side, everything except b is going to cancel out. And we have b is less than. And for this, what we could do is 12 divided by 3 is 4. And then 4 times 2 is 8. So our solution is going to be b is less than 8. Question 8, we want to know which table of values represents an exponential relationship. So for this one here, notice the x values are going up by 1 and the y values are going up by 3. So this one here is linear because once again, the slope, the y values are going up 3 as the x values go over 1. So this is a linear relationship with the slope of 3. If we look at choice 2 here, notice the x values are going up by 1 and the y values or the h of x values here are going up by 5. So this is also linear, so this answer is out as well. And once again, in this case, the slope is equal to 5. So if we look at the third one here, notice from 4 to 16 is a jump of 12, but then from 16 to 64 is a jump of, that looks like 48. So that's not linear because we're not jumping up by the same amount in the y column each time. But this is looking exponential. And what does this one look like if I had to write an actual function for k of x? Just thinking about this off the top of my head, these look like powers of 4. And this looks like 4 to the x power. And if we check this out, k of 1, 4 to the first power is equal to 4. 4 to the second power is 16. To the third power is here. And we just keep doing times 4. And this is looking like it. Now, if I look at this last one here, why is this not the answer? Well, if we look here, the x values are going up by 1, but it looks like this time around the y values are decreasing by 2.5. So here it looks like we have, once again, a linear relationship for choice 4. And this time around the y values are decreasing by 2.5 as the x values increase by 1. So this is a linear function with the slope of negative 2.5. So definitely choice 3. Question 9, which expression is not equivalent to this one? So what my first instinct is here is to just expand this. And just know in algebra, when you have a power or an exponent raised to another exponent, you multiply those exponents. So this would be a to the b times c. So what I want to do here is I'm going to call this 5 to the 2x times 3 is 6x. So then when I'm going through these questions, I say, all right, 5 to the x to the 6 is the same thing as 5 to the x times 6. Or 6 times x. So this one is equivalent. So this is not the answer because we need the one that's not equivalent. Now, if I go to the other answer choices, 3x times 2 is going to make 6x. So once again, I have a match. So this one's out. This is looking like the culprit right away, that this is going to be 5 to the 5x power when we multiply 5 times x. And now the last one, 5 to the second to the 3x, when you multiply 2 times 3x, that's going to make 5 to the 6x. So definitely choice 3. Now, an alternate solution for this last question is we could type in the question and all the answers. Now, we already did the algebra and said that this was the expression that was not equivalent to the original. But watch what happens when we graph all of them. The pink one should be the only one that doesn't line up. So you see how the pink one here, if we zoom in a little bit at the origin, the pink one is going to be the only one here that doesn't go completely over the others. You see, it goes a little bit off like this. So that's definitely our answer choice. Question 10, we want to know which relation is a function. So what I'm looking for here is repeating x values with different y values. So repeating x values will make something not a function right away. So you see how here we have repeating x values and they're going to different y values. So choice 1 does not model a function. Now, if I look at this one, another nice test to see if something is a function is the vertical line test. And what that means is if we draw a vertical line through the graph and the vertical line only touches the graph at one place no matter where we draw it, then it's a function. So right away, this is looking like a function because no matter where I draw our vertical line, it's going to hit at one location. So 10 is already looking like choice 3. But now what's the problem with this? Well, notice that x equals 2 shows up in both parts of this piecewise function. So what I could say is that if I plug in x equals 2 to the top, notice here, let's say I call this, I don't know, I'll just call this h of x since that's not taken. If this were a function, I could say h of 2, if I plug into the top part, is just equal to 2. However, h of 2 is defined by the bottom piece as well because 2 is less than or equal to x, and that would tell me h of 2 is equal to 2 squared, which is equal to 4. So there's my repeating x values with different y values, so that's why this one here is not a function. And if we look at the remaining answer choice here, notice x equals 3 shows up twice with different y values, so this one is out. So definitely choice 3 here. This one has a whole lot of words, but we're just solving this equation for y. So this is solving a literal equation. So we have ax plus by is equal to c. So to get y by itself, I'm going to subtract a times x first. And that's going to bring us here. We're going to have ax minus ax canceling. Now we have by equals c minus ax. And then to solve for y, just divide by capital B. So now we're just scanning the answer choices for c minus ax over b, and that matches choice 1. Question 12, we want to know the zeros of f of x. And notice f of x is already factored. So this, we set the factors. So we set the factors equal to 0. So if we set the first factor, 2x minus 4 equal to 0, you add 4 to both sides, you're going to have 2x equals 4, and now divide both sides by 2, and x is equal to 2. So right away, x equals 2 has to be in our solution set. So this is out and this is out. And now if you set the second factor equal to 0, you're setting 3x plus 4 equal to 0. You're going to subtract 4 on both sides. That's going to give you 3x equals negative 4. Divide both sides by 3, and that tells you the other 0 is going to be x equals negative 4/3. So definitely choice 1. Question 13, we have a nice piggy bank question. And just know a dime is worth 10 cents. We could write that as 0.10. And a nickel is worth 5 cents. We could write that as 0.05. And the amount of money in the piggy bank in total is $1.45. So here we're letting D represent dimes and N represent nickels. So what we have right now is that we have 0.10 times D plus 0.05 times N is equal to 1.45 like this. So this is our primary equation, but the other important piece of information here is that the number of nickels he has is 5 more than twice the number of dimes D. So think about that very carefully. The number of nickels is, so I like to write is in math means equals. 5 more than means plus 5, and then we have twice the number of dimes. So that tells us that N is equal to 2D plus 5. So we're going to replace this N with 2D plus 5, and that's going to give us, we have 0.10 times D plus 0.05 times 2D plus 5, and that's going to be equal to 1.45. We're not actually solving this out. We just have to be able to set this up. And if you scan the answer choices here, you're going to see that this matches up with choice 1. Question 14 is a stats question. We have Donna and Andrew, and we want to know which information about their final exam scores is correct. And notice this terminology. We have the phrase mean, median, interquartile range, and third quartile, all this information, which we could find all in the calculator. So let's go ahead to the stats button here, and we're going to edit the table. So Donna's numbers, we have 90, and then we're just going to type them all in. We had 90, 92, then there was 87, we had 94, and we had 95. And all at once, what I'll do is I'll just type in Andrew's scores as well in the column next to it. So we had 78, so that was Andrew's first score, 96, then it was 87, next up was 94, and then last here was 93. And then what we're going to do from here is we go to stats, calculate, one variable stats, and first we'll do it for Donna's. So if we calculate all this, this gives us all the information we need. So this X with the bar means the mean, and then we have all the other important information here if we scroll down. So we have the min, the first quartile, the median, the third quartile, and the max value here. And now we'll repeat this process for Andrew. So we're going to press stats again. We're going to go over and calculate single variable stats, but instead of L1, we're going to type in L2, which we could get by pressing second number 2 here. And we're going to calculate the single variable stats for Andrew. So notice what we have. We have an average of 89.6, and then we have the min, max, the quartiles, and the median. So now I'll just record all these values down. So now we could go through these answer choices one by one. We have Andrew has a higher mean than Donna. Well, if we look at this one, the mean is the one with the X and the bar over it. That's the average here. And Donna clearly has a higher average than Andrew. So choice 1 is out. Donna and Andrew have the same median. That's not correct because Donna's median is 92 and Andrew has a median of 93. So this one is not true. For choice 3, we have Andrew has a larger interquartile range than Donna. To calculate that, we have to do Q3 minus Q1. And if we do that for both of them, notice Q3 minus Q1 over here. If we do Q3 minus Q1, 94.5 minus 88.5 is equal to 6. But if we do that over here, Q3 minus Q1, we're going to get 95 minus 82.5, which is going to be equal to 12.5. So Andrew's interquartile range is definitely greater than Donna's. So this is the one. So now we just rule out the last choice. The third quartile for Donna is 94.5, is greater than 95, which is Andrew's, is not true because 95 is bigger than 94.5. So that's out, definitely choice 3. Question 15, we have the first term of a sequence is 5. So I'll write a sub 1 is equal to 5. And then what we have a sub 5, the fifth term is equal to 17. We want to know what is the common difference. So the phrase common difference tells us that this is an arithmetic sequence, which means to get from one term to the next, we're adding the same number each time. So to get to the second term, I'm adding the value d. And then to get to the third term, I'm going to add the value d again. So I'd have 5 plus d, which is going to be equal to 5 plus 2 times d. And then I think we see the trend here that the fourth term would be 5 plus 3d. So that means the fifth term is going to be equal to 5 plus 4 times d. So now we just have a little bit of algebra to do here. We could say 17 is equal to 5 plus 4d. And now just do the algebra. Subtract 5 on both sides. 5 minus 5 will cancel, and you'll have 12 equals 4d. And now after you divide both sides by 4, that tells you the common difference is equal to 3. So definitely choice 3. Question 16, we have a quadratic and linear function graphed on the same set of axes. And we want to know which situation is not possible. So for this, I would just think about what are the possible situations. And what I think about right away here is that there were 3 possible situations. No matter what the quadratic looks like, if it's smiling or if it's frowning, we could have the line and the parabola miss completely. We could have the line and the parabola be tangent at one point here. So that means we'd have one common solution between them. Or what we could have is we could have a quadratic being intersected by the line at 2 locations. So the possibilities here is that we have 0, 1, or 2 solutions between both of them. So the graphs do not intersect, that's possible. They intersect at 1 point, that's possible, that's the second case. They intersect at 2 points, that's possible, that's this third case. But there's no way for us to draw a line and a parabola so that they intersect 3 times. So definitely choice 4. Question 17, we could use that same trick from before. We could graph this in the y1 spot, and we could graph all the remaining answer choices to see which one overlaps the original graph here. Or what we could do is say m minus 3 squared is equal to m minus 3 times m minus 3, and just do the algebra. We have m times m is m squared, m times minus 3 is minus 3m, and now we distribute the negative 3. Negative 3 times m is minus 3m, and then minus 3 times minus 3 is plus 9. And now just combine like terms. We have m squared minus 3m makes minus 6m, and we have plus 9. So this is looking like choice 3. Question 18, we have this teacher asked her students to explain why 3 negative 4 is a solution to this equation here. And now here are the 3 responses. So Andrea says when the equation is graphed on a calculator, the point can be found within its table. So yeah, that's definitely a valid way to verify that this is a solution because it showed up in the table, which is something that we did before. Substituting x equals 3 and y equals -4 into the equation will make it true. So yes, that's a valid way to do this. If we said 2 times -4 plus 3 times 3, that's going to give us -8 plus 9, which is equal to +1. So yes, substituting in makes this true, so this is definitely a solution. So Andrea and Bill so far are both correct. And now we have the graph of the line passes through the point 3, -4. So this is also true. This is a visual representation, this is a numerical representation, and then this is like more of an algebraic approach by plugging in. But all three of these students are correct, so choice 4 is our answer. Question 19, we have 4 quadratic functions, and we want to make a statement about the maximum, and we want a true statement. So when I think maximum of a quadratic, I'm thinking vertex. So the table is arguably the easiest one to find, because notice here that the turning point occurs at -1, 5. So this one, the vertex, is at the point -1, 5. So our maximum here, this is going to be our maximum function value. So the max is going to be equal to 5. Now, looking at the second representation, g of x, what comes to my mind right away is this equation, a times x minus h squared plus k. This is the vertex form of a quadratic, and the vertex is going to be at hk. So this one would have a vertex of 4, 5 like this. So this one has a max value of 5 as well. So right away I'm seeing f of x and g of x have the same maximum. So right away choice 3 is looking good, but we'll just see why the other ones are no good. So let's look at this one. H of x has a maximum here at this vertex, which is at the point 1, and then we're going up 1, 2, 3, 4. So the vertex is at 1, 4, and that's our max for h of x. And for the last one here, this is probably the most annoying one to find. The vertex of a quadratic equation we could find using this formula, -b over 2a. And notice here that a, the coefficient of x squared, is -1/2, and the b value is the coefficient of x is equal to 1. So I would have x equals -1 over 2 times -1/2. And if we work this out, the negative over negative goes positive. 2 times 1/2 is equal to 1. So this tells us the maximum occurs at x equals 1. So I'd have j of 1 is equal to -1/2 plus 1 plus 4. So this, we would have 5 minus 1/2, which is equal to 4.5. So the vertex would be at 1, 4.5, and that would be the max of the last one. So this helps eliminate the other choices. The maximum of f of x is 5 is less than the max of j of x. That's not true because 5 is bigger than 4.5, so this is out. The max of g of x is 5 is less than the max of h of x, but h of x, the max is 4, so this one we have a max for g of x was 5. 5 is not less than 4, that's why this one's out. Now the last one, the maximum of h, and the max of h is 4 equals the max of j of x, which was 4.5. Those are clearly not equal, so this is out, definitely choice 3. Question 20, we're looking for an example of a 6th degree polynomial. So right away, if it's a 6th degree polynomial, that's the highest power of x that shows up, and that's x to the 6. And it has a leading coefficient of 7. So that means in front of the x to the 6, we need a coefficient of 7, and then we have plus blah, blah, blah. The constant term at the end is 4. So whatever is at the end just has to be a plus 4. So now we look for this in the answer key here. So just know the degree of a polynomial is not the first term. It just has to be the highest power that shows up. So notice here, x to the 7 is no good because this would be a 7th degree polynomial. And then choice 2, we have 7x to the 6, and notice the constant term is 4, so this is looking good, but let's rule out the others. This is a degree 4 polynomial because the highest power of x is x to the 4. Now this one, it's a degree 6 polynomial, but the leading coefficient is 4, not 7, and the constant term at the end is 7, so this one is out, so definitely choice 2. Question 21, there's a lot going on, but we have this equation here. We're told what each term means, and we want to know which statement correctly relates the information regarding the annual interest rate for each given equation. So we have to just go through this one by one. Now, the first thing that jumps out at me here is that we have a equals, and we have this expression here. But when I look at this, I immediately think of that as 1 plus 0.025. And when I pay attention to the decimal at the end, that tells us r equals 0.025, which is the same thing as 2.5 out of 100. So when I look at this, this tells me as a percent, this is 2.5%, which doesn't match the 25% here. So this answer choice is out. If we wanted to have a principal amount increasing at 25% interest, then it would be P times 1.25 to the T power. Because notice here, 25%. 25% is the same thing as 0.25. Okay, so the decimal is just a little bit off, but in math, if you're a little bit off, it's not going to work out. Now for this next one here, this one, what I noticed right away is that we have 1 plus 0 point, and we have 2 zeros and a 5-2 here, but the principal amount is increasing at an interest rate of 52%. That's no good because 52% is the same thing as 0.52. But notice the decimal here, there's 2 zeros after the decimal, whereas with 52%, it's just decimal and then 5-2. So this is not going to be the answer. So now we move on to the other answer choices here, where the principal amount of money is decreasing. So for decreasing, you have 1 minus the interest rate. So here, it's looking like choice 3 is the one, because if we're decreasing at this interest rate here, just know 0.14 is equal to 14%. Because 14% is the same thing as 14 over 100. So these three things are equal here. So if I do 1 minus the interest rate, 1 minus 0.14, that's going to give us 0.86, which matches the decimal next to the letter P here. So this is the one. The reason why choice 4 is no good is because if the principal amount is decreasing at 68% interest, then we would have 1 minus 68% is the same thing as 0.68, and that would be equal to 0.32. And that's what would be inside of the parentheses here, not 0.68. So that's why this one is out here. Definitely choice 3. Question 22, we have to be good with conversion factors. And we have Tim takes 4.5 hours to run 50 kilometers. And we want to know which expression will allow him to change this rate to minutes per mile. So what I'm checking with all these answer choices is that we're starting with the 4.5 hours per kilometer here. And we want to see everything cancel out so that we're left with minutes per mile. And what I mean by cancel out, anytime you have a matching unit on top and bottom, they could cross off like this. So hours over hours cancel, kilometers over kilometers cancel. And notice we're left with minutes and we're left with miles on bottom. So minutes per mile, this is already looking like the answer, but I'm going to show why the other ones are no good. So here, kilometers over kilometers cancels. And the problem with this is that when we do hours times hours, we're going to have hours squared on bottom. And on top, we're going to have miles times minute. And notice that doesn't match minutes per mile. We have all this extra stuff here. So that's why this one's out. And if we look at the others, kilometers cancels. And we also have here hours canceling. But this, we would have some number, and we would have miles per minute. But what we want is we want minutes per mile, not miles per minute. So this, they're flipped the wrong way. So 3 is out. Now here, hours over hours cancels. And we would also have here, let's see, kilometers times kilometers on bottom is a problem because we have some number. And kilometers times kilometers gives us square kilometers. And then we have miles times minutes on top. So notice this doesn't match minutes per mile. So 4 is out. Definitely choice 1. Question 23 is all algebra, and we're solving for x, and we want our answer to be in terms of a. So what I noticed right away is that if we're solving for x over here, I'm going to add everything else to the other side first. So I'm going to add a over 4 to both sides. And if we do that, a over 4 and a over 4 here both cancel because they're opposite signs. And now we're going to be left with x minus 1 over 2. So that's all that's left on the left side. And this is going to be equal to, and notice we're adding fractions that have the same denominator. So that means we're going to add their numerators. If I had something like 1 over 7 plus 2 over 7, what I would do is I would add 1 plus 2 is 3, and I would keep the denominator as 7. So using that idea, 3a plus 1a is equal to 4a, and we're keeping the denominator as 4. Now 4 over 4 could cancel out because those are matching factors. And now we have x minus 1 over 2 is equal to a. So now to solve for x, we could multiply both sides by 2. And now 2 over 2 cancels, and you have x minus 1 is equal to 2 times a. And now just add 1 to both sides. And this tells us that x is going to be equal to 2a plus 1, so definitely choice 4. Question 24, we have a recursive sequence, and we're given the first term, and then we're given the general term. And now just know a recursive sequence is built by the terms before it. Okay, so that's what I think of when I hear recursive here, is that it's built by the previous term. And that idea really helps when you're going through questions like this, because if a1 equals -3, that tells me that a sub 2, notice in this case here, n is equal to 2, because I'm replacing the subscript n with 2, is going to be equal to -3 times, and if n is equal to 2, 2 minus 1, see how we have a sub n minus 1? I would have a sub 2 minus 1 is a sub 1, and then I just tack on the minus 2 at the end. But notice what we get here. We get -3 times a sub 1. See, we're building it by the previous term. So we're replacing a sub 1 with -3, so we have a -3 here minus 2, and now this gives us 9 minus 2, which is equal to 7. So that's our second term. And now our third term, we'll start to build up speed here, is going to be equal to -3, and now this is n equals 3, so I would have -3 times a sub n minus 1, and if we replace n with 3, 3 minus 1 is 2, so I get -3 times a sub 2, and I have minus 2 at the end of all that. But notice, -3 times the one we just found before it is giving us 7. We have minus 2, so this is -21 minus 2, which is -23. So now for the last term here that we need, a sub 4, is going to be equal to -3 times, and now we have n equals 4, which would give us -3 times a sub 3 minus 2, because once again, if I replace n with 4, 4 minus 1 is 3. And now I have -3 times -23 minus 2. And for this one here, if I work this out, -3 times -23 is going to give us 69 minus 2, which is going to give us 67. So this is definitely choice 4.